Like, share, subscribe, and do press the bell icon to get latest videos.
Purpose of this channel is to give initial guidance to newcomers in the field of electronics who want to explore the ocean of infinite possibilities but are not able to do so due to lack of basic understanding. Content is more towards the practical application with a little theoretical part to make it easy to understand the circuits we are going to make further. It is very important that you go through all the lessons one by one to have better understanding. Videos and guidance are not enough to make you experience the fun, so viewers are requested to do the things practically. In the end, I request you to be very careful while handling electricity, as, if care is not taken, then it may be fatal. So get ready to dive in. Let your imagination create miracles. In Lesson 1, we will discuss basic tools required for the projects, and basic electronics components. We will require these basic tools to go ahead, which can be had from local hardware shops or can also be purchased online. Flathead and Phillips head screwdriver, long nose plier, wire stripper, 12 volts and 5 volts, 2 ampere DC adapter, 35 watt soldering iron and wire, desoldering pump, connecting wire, multimeter, general purpose PCB, breadboard, breadboard wire set, male to male, female to female, and male to female, 20 each. In today's lesson, we will discuss about battery, power supply, transformer, resistor, capacitor, diode, LED, relay, transistor, power regulator IC, and IC. Cell is a handy source of energy. DC, direct current, cells in series one after another are called battery. Drawback of these are that these can supply fixed voltage, are costly, and their lifespan is short. Rechargeable cells are available but are very costly. If not used properly, they can even blast. It is advised to use them when possibility of alternate power source is not possible. When connected in series, the voltage increases. And when similar cells are connected in parallel, the current increases. Voltage remains same. These are available in various voltages like 1.5 volts, 3 volts, 5 volts, 9 volts, 12 volts etc. and various current ratings. To replace cells, we can use power supplies. These are handy, economical and long-lasting. They operate on mains supply and are available in various current and voltage ratings. Care should be taken while using them, as there is possibility of electric shock if not used properly, or if the power supply is defective. Most commonly used power supplies are 3 volts, 5 volts, 6 volts, 9 volts, 12 volts, 24 volts with current ratings from as low as 500 mA to 5 amperes. Power adapters and SMPS, switched mode power supply, normally deliver fixed voltages, whereas benchtop variable power supply provides adjustable voltage ranging from as low as 2 volts to 24 volts. These are slightly costly, but are recommended as single unit serves the wide voltage range. Transformers work with AC, alternating current, only, and are used to step up, increase, or step down, decrease, the voltage. In most of our projects we will use step-down transformer. Transformer have 2 coils, primary and secondary. Input voltage is supplied to primary coil, and output is derived through secondary coil. Transformer are available in various current and voltage ratings, like 12 volts, 1 ampere, 6 volts, 500 milliamperes etc. Illustration below shows 220 volts AC to 12 volts AC transformer. Resistor is used to reduce the voltage to desired level. It also reduces the current flowing through it. Basic value of resistor is measured in ohms, the amount of current flowing through. Resistor is controlled by watts of resistor. Commonly used are 1/4 watts, half watts etc. Value of resistor is determined by color bands printed on it, as shown below, or can be done by a multimeter. To remember the color sequence easily, learn the following sentence. Buy, better. Resistance, or, your grid. Bias, voltage may go wrong. Potentiometer is variable resistance, also known as pot or preset. These are available in kilo ohms, mega ohms, etc., and center pin is connected to a wiper, which, when rotated, gives various resistance values, ranging from 0 ohms to the value of the preset. These are available in different packages and values like 1K, 10K, 100K, 1M, etc.
Capacitors are used to store energy, charge, which can be discharged as per circuit requirement. Their unit of measurement is microfarad and they also have maximum usable voltage limit. We will use mainly electrolytic or ceramic types of capacitors in further lessons. These capacitors can be used as filters also. In most of the cases they allow AC, alternating current, to pass, but blocks the flow of DC, direct current, through them. Electrolytic capacitors have polarity, positive and negative, and minimum value of 1 microfarad. If connected in wrong way, they can get damaged or even blast. Example, 10mF50V indicates it is 10 microfarad capacitor which can be used max with 50V. For electrolytic capacitors, value is printed on capacitor and negative pole is indicated by minus sign printed on capacitor, whereas nonpolar capacitors do not have plus or minus poles and are of very low values like 0.1, 0.01, 0.001 microfarad, etc. Diodes are semiconductor device and can be assumed to be a one-way valve for electric current. They conduct when forward biased, that is plus supply is at anode and minus supply is at cathode. If connected in reverse biased mode then it won't allow the current to flow through it. These are usually used to make rectifiers, to convert AC into DC, and to protect devices if connected in reverse polarity. These are available in various current handling capacity ratings. These are identified by names like 1N4001, 1N4007, etc. LED, light-emitting diode, are same as semiconductor diodes, only difference is that they emit light in forward-biased mode. Just like diodes, they also have anode, positive, and cathode, negative terminals. When connected in reverse, they won't emit light. If used with overvoltage, they will burn out. These usually operate on 2 volts to 3 volts and are available in various colors like red, green, yellow, blue, white, orange, etc., and also in various shapes and size. Relay is an electromechanical switch, which operates on basis of flow of current in coil. It has 5 terminals, 2 for coil, common C, NC, normally closed, NO, normally open. Coil points are used to energize coil, whereas C, NC, NO are used as switch to operate device. When there is no current in coil, then C and NC points are in contact to complete the circuit with load, whereas C and NO points are open, thus making open circuit, and when current is supplied to coil, then the electromagnet attracts the red strip, thus now C and NC points are open and C and NO points are closed. Relays are available in various coil voltages, 5V, 6V, 12V, 24V, etc., and contact point, NO, C, NC, current handling capacities, 1, 2, 5 amperes, etc., and also on basis of contact points, 1, 2, 3, etc. Transistors are semiconductor devices and are commonly used as an amplifier. When there is slight change in voltage at base, then they amplify the change and generate proportionally high difference in current flowing between emitter and collector. These are available in various packages as shown below and are identified by name. Like BC 547, BC 548, BC 558, to N6058 etc. '78XX series IC are used as voltage regulator where XX, last two digits, indicate the output voltage. Example 7812 will give output voltage of 12 volts, these are to be used with DC only. It is advisable to use these with heatsink as they dissipate heat while operating. Example, if you have 12 volts power supply and you need 9 volts, then you can use 7809 IC. These are available as 7805, 7809, 7812 etc. IC, integrated circuit, can be assumed to be a very complex circuit, pre-assembled in a very small area, with many pin coming out to be used in some other circuit as per your requirement. There are numerous ICs available with specific use which we will go across in our upcoming lessons as per requirement. Shown below is commonly used 555 IC which can be used as flip-flop, oscillator, timer etc. Here focus is on identifying the pin number of the IC. If you keep the semicircle cut, indicated by gray arrow, or the small circle, yellow arrow, to your left, then the left pin on bottom side is pin number 1, then going counterclockwise comes pin number 2, 3, 4, 5, 6, 7, 8. This holds good for all similarly packaged ICs, irrespective of number of pins they have. So here we come to end of lesson 1. Hope you enjoyed. Now till we get back with lesson 2 from where we will start our practical journey, please arrange the tools and some components to experience the fun. And please do like, share, and subscribe the channel. Bye for now. Have a nice day.